All right. So we take a look at a couple of these. We've got F smoosh poosh, guy comma floor, FG, guy comma earth. And you see there's tick marks on these arrows. So when you fab these arrows, you end up back at the beginning. And yeah, you can just use the text tools. You don't have to try to write that. That's difficult. Challenge accepted, I guess, right? And then, poo, okay? The other one I was going to show had more than two forces, but keep in mind, it's interacting gravitationally with the Earth, and then the only other thing the guy is touching, I don't know if I'd call it the floor. What's he touching? Hayden, hey, what's he touching?
The elevator.
Is he touching the elevator? Here we go.
What happens to your weight in an...
What's he touching? Scale, right? He's standing on the scale. Mitchell. I woke up like half an hour late. I still got
elevator? What does the 100...
All right. So that's what's happening. That's why the velocity is constant there. It's constant 0. Because you got, if we were to put number values to it, you got 157 pounds down, you got 157 pounds up, okay? All right, so then what about when the scale reads 212 pounds? If our baseline free body diagram in situation 1, I should be drawing it as a note, shouldn't I? Is that somebody sneeze? What is that? No? Okay, so in situation 1, you had FG, you had F smoosh poosh. This is guy, comma scale. Wow, come on, thing. That is just sad. My handwriting's bad enough on its own. I don't know what to tell you. I'm supposed to say guy, comma earth. So you're thinking about the situation now 2. The scale reading is 212. What's the free body diagram going to look like? Again, I'm asking you to draw the free body diagram now when the scale reads 212. Join us, friends. All right, let me hold it for a second. I want to show you what I have in here so far. And if we go like this. So we've got one like this. You got Smoosh Poosh Man scale. You got Gravity Man Earth. But now I think they're showing you a difference in those forces. Okay. Here's one showing these two forces are still the same, but there's additional force down. Here's one showing 212 up and 212 down. Here's one showing 212 up and 157 down. Okay? So this is situation 2 that we're talking about right now. Situation 2, should there be more force down than up? Should there be a new force? Should there be the same amount of force down and up? Should there be more force up than down? I need you to ponder that with your neighbor. And this is kind of a key discussion for understanding and shoot it well. So I need you involved in this discussion with your neighbors. What do we got to do to the three-body diagram here? This is situation 2 when it starts out moving. Well, I just need you talking about it right now. I'll unlock you here in a second. All right, I'll freeze it. All right, now you can go back to your diagram. And what are you thinking? More force down than up, an additional force, same force down and up, more force up than down. Starting out at the ground level. All right, so you should be able to change your three-body diagrams right now. You go in and alter what you have there, but I need you talking about it with your neighbor. What seems like this thing starts out at the ground level. It was at rest a moment ago, but now it's beginning to move upwards, and the scale reads 212. Did we do a lab with bowling balls in here? Did that happen?
Yeah.
I'm not making that up. Bowling balls and mallets? Yeah. Okay.
Are you serious? I'm very bottom.
All right, I'm going to shut it down again for a second. I'm glad to see more of you in there. So now it's, I don't want that button. What do you do? There we go. Now it's kind of breaking down like this. We've got a number of people that have more force up than down, but we also have a number of people that have more force down than up. This thing wasn't moving, but now it's speeding up in the upward direction. The scale reading is now 212. So I need you to chat with your neighbor about that a little bit. Why shouldn't I have a third arrow in here? During this time when the scale reads 212, he's interacting with the Earth gravitationally. What is he touching? The scale. He's still just touching the same thing he was touching before. So I just have two arrows, but how do I get it to speed up in that direction that it's moving? If you think back to that bowling ball lab that we did way back when, this ball's not moving. I want it to speed up going that way. I've got to have an unbalanced force in the direction that I want it speeding up in. Okay? So what's my additional force in the direction of motion? Keep in mind the motion is up like that. I've got FG down, that's 157 pounds, unless he eats too much like Mr. Harding over winter break, okay? Or he takes a massive poop. This is not changing. He's still the same mass. He's still feeling 157 pounds from the earth. The 212 pounds, that's the reading on the scale. That's his interaction with the scale. If I do a force addition diagram for that, I'm going to have 212 pounds up. I'm going to have 157 pounds down. Is that balanced? How not balanced is it? £55. Which direction is the excess force? Up. So I don't want to draw an arrow that's going to balance this. I want to draw an arrow that shows how unbalanced it is. This is going to be my FU arrow. Okay? It's FU because it doesn't follow your rules. It puts its butt on another arrow's butt. It puts its head on another arrow's head. Okay? So that's showing how unbalanced the forces are right now. Right now they're unbalanced by 55 pounds in the upward direction. It's moving up. It's accelerating upward as well. I want to make a note of that somewhere maybe. That the motion is up. The acceleration is up. The FU is up here. It's effed up, kids. All right. So, let's see. So the next one then. This is for situation 3. The scale reading is again 157. But the velocity isn't 0 anymore. What is a free body diagram going to look like during this period of time when the scale reads 157, but it's in motion in the upward direction? Seriously. All right, where are we at? I don't need that button. Cool. So most folks are showing here equal forces in the up and down direction. It's got a constant velocity. The forces have to balance. It's not touching anything additional. So there's just two arrows, 157 pounds up, 157 pounds down. So here when the scale reads 157 pounds, you got 157 down, you got 157 up. It's BFPM because it's CVPM. Okay. If I add those two arrows, it's going to end up back at the beginning. FU is 0 there. So what about this next part then? Now we're in a situation where the scale reads 122 pounds. And it's slowing down to a stop. So what's your free body diagram going to look like? The scale reading is 122. Think about what that's telling you about the forces that are acting here. All right, so if you look at the examples here, we've got some with the FU pointing up, some with the FU pointing down, okay? Think about what happens to the bowling ball, or what happens to the direction I have to hit it with the mount when I want to stop it. So this is kind of like the bowling ball is the guy. If I want to get him to speed up, I got to hit him that way. But if I want him to stop, I got to get an unbalanced force going against its motion. Okay? So when you're drawing that diagram, the FU points opposite of its motion. It should have an FU in the downward direction.